So what if you were told that one single person, like just one guy whose name you might not even know, is credited with saving over 1 billion lives from starvation?
I mean, 1 billion human beings. It's a number that's almost hard to wrap your head around.
It really is. You really have to let that number sink in. We are talking about a scale of survival that completely reshaped the entire demographic map of the globe.
Absolutely.
So today we are doing a deep dive into the sole source material for this topic, which is this incredibly comprehensive biographical text on an American agronomist.
Norman Borlaug.
Exactly. And our mission today is to unpack how a farm boy from Iowa fundamentally re-engineered the global food supply. We're going to get into how he sparked what's known as the Green Revolution, averted this massive global famine, and, well, left behind a legacy that is just as incredibly complex as it is controversial.
Yeah, and I think what's so fascinating here, setting the tone for our listeners, is that it shouldn't just be about the sheer volume of lives saved.
Right.
It's about the granular, almost obsessive mechanics of how he actually pulled it off. We're looking at a man who synthesized biology, logistics, and just like sheer stubbornness to alter human history.
He weaponized science, essentially.
He really did. He weaponized it against the fundamental ancient human problem of famine.
Okay, let's unpack this. Because to understand how he fed 1 billion people, we first have to understand his relationship with hunger, like his psychological scars.
Or for sure, the resilience he had to build early on.
Right, because he wasn't born into some elite academia. He was born in 1914, grew up on a farm in a small Norwegian-American community in Iowa.
Yeah, working the land from day one.
Exactly. And the source mentions this profound, pragmatic advice his grandfather gave him early on. He said, "You're wiser to fill your head now if you want to fill your belly later on."
That is such a Depression-era mentality.
It really is.
And his path to actually filling his head was, well, is chaotic. When he applied to the University of Minnesota, he just flat out failed the entrance exam.
Wait, really? The guy who saves 1 billion lives failed his college entrance exam?
He did. He only got in because the school had this newly created 2-year general college program. But, while he was there, he actually joined the wrestling team.
Oh, wow. Big Ten wrestling, right?
Yeah, competing in the Big Ten. And his coach had this strict rule. He demanded that his athletes give 105% in every single match.
105%.
Exactly. And that phrase, that 105%, it basically became the psychological baseline for the rest of his entire life.
I find it so fascinating how physical his early life was. Like, it's like Borlaug's entire early life was a boot camp for crisis management.
Oh, that's a great way to put it.
Right, because he actually had to put his education on hold to go work in the Civilian Conservation Corps during the Great Depression. He's out there managing unemployed workers on these federal forestry projects.
And these were men who were quite literally starving.
Exactly. He was surrounded by starvation. And he noticed how just a simple hot meal changed them, not just physically, but psychologically, How hunger just erodes human dignity. He even noted later on, he said, "I saw how food changed them. All of this left scars on me."
And those visual memories of starvation, they moved hunger out of the realm of theoretical problems. It became this immediate physical enemy for him.
Definitely.
And we really see that pragmatism sharpen during World War II. I mean, he actually tried to enlist in the military.
But he got rejected, right?
Yeah, the government rejected him. They told him his job as a microbiologist at DuPont was deemed too essential to the war effort.
Which, sounds prestigious, but look at what he was actually doing. The U.S. military was facing this completely bizarre logistical nightmare in the Pacific Theater.
Right. Specifically on Guadalcanal.
Yeah, so the Marines are stranded on these beaches, and the military is having to airdrop boxes of canned food directly into the surf so they'd wash ashore.
Because they couldn't land the supply boats.
Exactly. But the problem was, the standard adhesive on the cardboard boxes was water-soluble. Yeah, so the boxes are hitting the warm salt water, the glue is completely dissolving, and all this life-saving food is just sinking to the bottom of the ocean.
Wow. So he applies that 105% mentality to industrial chemistry.
He does.
Within a matter of weeks, he and his team at DuPont engineered this brand new resin-based adhesive that completely resists saltwater corrosion.
Problem solved.
Literally, the boxes held together and the food actually reached the stranded troops.
So he's building this resume of extreme mental and physical toughness, wrestling, witnessing starvation, fixing wartime supply chain failures before he even gets to the actual plants.
Exactly. And these early experiences forged his core belief. He believed that theoretical science is just entirely useless unless it is actively applied to alleviate human suffering.
You don't want to just write papers.
No, he had zero interest in publishing papers just to have them read in faculty lounges.
Yeah.
He wanted tools that worked in the mud, in the surf, and, in the hands of desperate people.
Which completely explains his next move, because on paper, it otherwise makes no sense. It's 1944. He has this comfortable, well-paying, secure job at DuPont. But the Rockefeller Foundation and the Mexican government are starting up this cooperative program to try and boost wheat production.
Because Mexico was importing a massive portion of its grain at the time.
Yeah, and their farmers are just being decimated by this fungal disease called stem rust.
He was wiping out entire harvests.
So he takes a massive pay cut, leaves his pregnant wife and young daughter behind, and heads down to Mexico to face, hostile farmers, terrible soil, and basically zero lab equipment.
He was obsessed with practical solutions, and he needed the ultimate testing ground. So he spends his first 10 years in Mexico just trying to breed wheat cultivars that could actually survive that stem rust fungus.
But plant breeding, especially back then, is agonizingly slow.
Oh, incredibly slow. You plant the seeds in the spring, you harvest in the fall, and then you just have to wait until the next year to try a new cross. You only get one single iteration per year.
And he just decides that is way too slow, so he invents this process called shuttle breeding. During the summer, he'd breed his wheat in the central highlands of Mexico. Then, the second the harvest was done, he'd pack up the seeds and transport them 700 miles north to this research station in the Valle del Yaqui.
That is quite the commute.
I mean, he's crossing a 10-degree difference in latitude, dropping 8,500 feet in elevation just to force a second growing season into a single calendar year.
And the craziest part is that his boss, George Herrar, strictly vetoed it, forbade him from doing it.
Wait, the scientific consensus at the time was literally that seeds needed to take a nap. How did a foundational rule of agronomy turn out to be completely wrong?
Well, the belief was that seeds required a period of dormancy, a rest period after harvesting, to store up energy before they could successfully germinate again.
I guess that makes sense in nature.
It does make evolutionary sense. In nature, if a seed drops in autumn, it needs to sleep through the winter so it doesn't sprout in the snow and freeze to death.
So they thought you couldn't force a seed to grow immediately after harvesting it.
Exactly. And the reason the whole field got it wrong was just because no one had ever aggressively challenged that assumption with the kind of sheer brute force repetition he was using.
That 105% again.
Right. He was convinced that if you just planted enough seeds, some genetic outliers would sprout anyway. So when his boss vetoed the plan, Borlaug just resigned in protest.
I actually quit.
Packed his bags. The only reason he ended up staying was because his old mentor, Elvin Stackman, had to literally fly down to Mexico, mediate the dispute, and basically force the boss to let him try.
Wow. And that stubbornness triggers this monumental accident, because by moving these plants back and forth across wildly different latitudes and elevations, he inadvertently broke the plant's internal clocks.
Yeah, what the sources call photoperiodism.
Right. Usually, a plant measures the length of daylight to know what season it is and when it should flower. If you take a plant from the equator and put it in Canada, it gets super confused by the long summer days and just doesn't produce grain.
But because he was so rapidly breeding them in totally different altitudes and daylight conditions,
the resulting generations of wheat just stopped caring about the sun.
Exactly. If we connect this to the bigger picture, this shuttle breeding was a monumental paradigm shift. It didn't just save time, it accidentally created anywhere wheat.
Anywhere wheat. I love that term.
Yeah. These plants became insensitive to day length. So instead of running separate, highly localized breeding programs for every single microclimate on Earth, scientists suddenly had a universal chassis.
So you could plant it anywhere.
Anywhere. Pakistan, India, Argentina, the Middle East. It made a global agricultural revolution biologically possible almost overnight.
But adapting to sunlight is just one part of the battle. He still has to deal with the stem rust fungus. And the way he solved this just breaks my brain.
The multi-line.
Yeah, the sources mention back crossing and multi-line varieties. Can you actually walk me through the physical mechanics of this? Because, this is pre-CRISPR. He isn't sitting at a computer editing DNA.
Oh, not at all. It was painstaking, exhausting physical labor. You have to remember, a wheat flower is incredibly tiny, and it contains both male and female parts.
Okay.
So to crossbreed them, he and his team literally had to take tweezers carefully open the microscopic flower and physically snip out the male parts, the anthers, so the plant couldn't pollinate itself.
Using tweezers in the middle of a hot field.
Exactly. Then they'd cover it with a tiny bag. A few days later, they would take pollen from a different disease-resistant plant, manually dust it onto the female parts of the first plant, and then bag it again.
And they had to do this how many times?
Tens of thousands of times.
Yeah.
Out in the blistering Mexican sun.
Okay, so you meticulously build this disease-resistant plant, but fungi mutate rapidly, right? If the stem rust mutates to bypass that specific genetic defense you just built, your entire field dies anyway.
And that's where the multi-lines come in. He painstakingly bred different genetic lines of wheat that looked completely physically identical.
Meaning they grew to the exact same height.
The same height, matured at the exact same speed, and produced the exact same kind of flower. But each line carried a totally different genetic defense against the fungus.
Oh, wow.
Yeah, he would mix seeds from like 5 to 10 of these different lines together and just plant them all in the exact same field.
That is brilliant structural engineering.
Right.
Because if a new rust mutation evolves, it might successfully infect, say, line A, but then it hits a total brick wall when it tries to spread to the plant right next to it because that one is line B.
He's essentially building genetic fire breaks right into the crop itself.
But having disease-resistant, globally adaptable wheat wasn't enough, was it? Because solving the disease and daylight problems exposed a massive physical flaw in the plant itself.
It did. Because to push these resilient plants to produce massive yields, he was applying heavy amounts of synthetic nitrogen fertilizer.
And the plants literally couldn't handle their own success. It's this mechanical failure called lodging.
And lodging.
Nitrogen makes the cellular structure of the stem grow incredibly fast, but the cell walls end up thin and weak. So you get these tall, spindly stalks carrying these massive, heavy seed heads.
And the first gust of wind.
Or heavy rain, yeah. And the plants just snap, or they flop over into the mud and the grain rots. It's like putting a heavy sports car engine onto a lightweight bicycle frame. The frame is just going to snap. He had to completely redesign the chassis of the plant.
Exactly. So in 1953, he gets a hold of this really fascinating genetic tool. It's a Japanese dwarf variety of wheat called Norin-10.
Norin-10.
Yeah, and these plants were thick, short, and incredibly sturdy. So by crossbreeding this semi-dwarf wheat with his disease-resistant Mexican varieties, he engineered a compact plant that could absorb all that nitrogen and hold up those massive seed heads without collapsing.
And the results were just staggering. By 1963, 95% of Mexico's wheat crops were using his semi-dwarf varieties.
The national harvest was 6 times larger than when he first arrived.
6 times. Mexico literally flipped from being a desperate importer of grain to a net exporter. But while Mexico is stabilizing, there's this terrifying demographic crisis brewing in South Asia.
Yeah, the 1960s were characterized by this deep existential panic about global food security. You had people like the biologist Paul Ehrlich publishing The Population Bomb in 1968.
Right, predicting that hundreds of millions of people were going to starve to death in India and Pakistan.
Ehrlich specifically pointed to India and basically asserted it was a lost cause. He said they couldn't possibly feed their exploding population.
So facing this totally apocalyptic prediction, Borlaug and his team decided to just brute force a solution. In 1965, they organized this massive shipment of their semi-dwarf seeds to India and Pakistan.
And the logistics of this shipment, I mean, it reads like a geopolitical thriller.
It really does. It's not just putting some bags of seed on a boat.
Not at all. First, the seeds get totally jammed up in Mexican customs, so they have to load the shipment onto a 30-truck convoy just to drive it up to the port of Los Angeles.
And then they hit delays at the U.S. border.
Right. And when they finally cross into California, the Watts riots have erupted in Los Angeles, and the National Guard has completely shut down the freeways.
It's just one disaster after another. They finally get to the port, and the bureaucratic nightmare continues. A Mexican bank refuses to honor a $100,000 check from the Pakistani treasury, all because 3 words are misspelled.
You can't make this stuff up.
You really can't. They finally managed to load the freighter, set sail, and literally 12 hours later, full-scale war breaks out between India and Pakistan over the Kashmir region.
Right.
The Pakistani Minister of Agriculture actually sends a telegram apologizing for the misspelled check and casually adds, "Bombs are falling on my front lawn."
But the real crisis happens when the seeds actually arrive in South Asia.
Right, because of the warehouse in Mexico.
Yeah, while they were sitting in storage back in Mexico, the seeds had been aggressively over-fumigated with pesticide. When they finally tested the germination rate in the soil over in South Asia, less than half the seeds were actually sprouting.
So what does he do? He's standing in these fields in South Asia, literally watching artillery flashes on the horizon from an active war zone, and he just orders everyone to double the planting rates.
It's incredible.
He's like, if half the seeds are dead, plant twice as many. He's adjusting the math on the fly under mortar fire.
And that perfectly encapsulates his entire ethos. He wasn't just a scientist in a lab. He was a supply chain general fighting a literal and metaphorical war.
Yeah.
And the gamble paid off completely. The resulting harvests were so massive that they actually broke the local infrastructure.
They literally didn't have enough laborers to harvest it all. They didn't have enough bullock carts to haul it. Local governments had to temporarily shut down schools just so they could use the classrooms to dump the surplus grain.
It's an amazing image.
Pakistan became self-sufficient in wheat by 1968. India became self-sufficient in all cereals by 1974. 1 billion lives saved. That sequence of events is the Green Revolution.
Which is exactly why, in 1970, he was awarded the Nobel Peace Prize.
And true to form, he wasn't exactly sitting by the phone in a tuxedo waiting for the call.
No. The call came at 4 a.m., and he was already out in the Mexican test fields. His wife had to send a chauffeur out into the mud just to relay the news.
And he thought it was a hoax at first, right?
He absolutely thought it was a practical joke.
So what does this all mean? Because saving 1 billion lives seems like an unalloyed good. But when you alter the baseline biology of global agriculture, you rewire entire ecosystems and societies. We really have to look at both sides of the coin here for you, the listener.
This raises an important question, yes.
On one hand, mass starvation is averted. On the other, we are totally changing the chemical and social makeup of global farming. And this is where the legacy gets deeply complicated.
We definitely have to look critically at what economists call the Borlaug hypothesis. His central defense of high-yield farming was intensely mathematical.
Walk me through the math on that, because it's a very counterintuitive way to view environmentalism.
Okay, so he argued that by drastically increasing the caloric output of the world's most arable farmland, using these specialized seeds and synthetic fertilizers, you actually eliminate the need to slash and burn virgin forests to create new farmland.
So high-density farming saves the forests.
Exactly. If you look at the global grain output today and you ask, how much land would we need to produce this exact same amount of food using the low-yield traditional farming methods of the 1950s?
Right.
The answer is staggering.
Yep.
We would need an additional land mass roughly the size of South America.
Wow.
We would have to plow into the Amazon basin, the forests of Central Africa, just massive tracts of wilderness to keep everyone fed.
Yeah.
He believed high-yield, chemically intensive farming was the only thing standing between humanity and total ecological deforestation.
But the critics strongly disagree with that framing, and the pushback is severe. For one, non-scientists and environmentalists viewed the intensive crossbreeding as unnatural. And when you transition millions of acres to identical semi-dwarf wheat, you severely reduce biodiversity. If a pathogen ever did break through those genetic fire breaks, the monoculture vulnerability is just terrifying.
It's a huge risk.
Plus, there is the massive reliance on inorganic fertilizers, herbicides, and pesticides, including DDT, which Borlaug actually defended for its use in malaria control and crop protection.
And the socioeconomic critique is just as sharp. You have figures like the Indian environmentalist Vandana Shiva, who pointed out that these methods required really expensive seeds and chemical inputs.
Right, which heavily favored wealthy landowners.
Exactly. Those who could afford the upfront costs thrived, while smaller peasant farmers were driven into crushing debt and often forced off their land completely.
And there were accusations that this was forcing U.S. capitalist and agribusiness agendas on developing nations.
Yes. Alexander Cockburn, a political commentator, even argued that the ensuing rural displacement and poverty made our Nobel laureate the biggest killer of all.
Let me push back on how we frame his response to that, because he didn't just quietly absorb the criticism. He was furious.
Oh, he was extremely vocal.
He called Western environmental lobbyists elitists. He argued that they sit in these comfortable office suites in Washington or Brussels and dictate agricultural policy without ever having felt the physical sensation of starvation.
He essentially said, go live for a month in the misery of the developing world, and you will be begging for tractors and synthetic fertilizer. It reveals a profound philosophical divide, doesn't it?
It really does.
He was a pragmatist forged in the Great Depression. He prioritized immediate human survival and caloric output above theoretical ecological purity. But, he also wasn't arrogant about his solutions. He repeatedly warned that there are no miracles in agricultural production.
Every solution breeds new challenges.
Right. No single seed is a silver bullet.
Here's where it gets really interesting. Borlaug is in his 70s. He's already saved 1 billion people. He could easily just retire. Instead, he looks at Africa and says, let's just start growing.
Which was incredibly difficult because those controversies we just talked about didn't stay theoretical. They had immediate geopolitical consequences.
Right. In the early 1980s, the environmental lobbying he hated so much actually successfully pressured organizations to stop funding inorganic fertilizer for Africa.
They essentially blocked the chemical inputs that were completely necessary for the Green Revolution.
Which obviously deeply frustrated him. But then, during the horrific 1984 famine in Ethiopia, this Japanese philanthropist named Ryoichi Sasakawa reaches out.
Yeah, Sasakawa wanted to know why the methods that saved India and Pakistan weren't being deployed in Africa. And he manages to convince our aging agronomist to come out of semi-retirement.
But wait, how do you even begin to replicate the Green Revolution in Africa at that time? In India, they had railways, they had a functioning credit market for farmers, irrigation systems. In many parts of sub-Saharan Africa in the 80s, you have literally none of that.
You're exactly right. The infrastructural deficit was massive, and that's why they brought in former U.S. President Jimmy Carter. Carter used his geopolitical leverage to speak directly with African heads of state, basically bypassing the World Bank's blockades. Meanwhile, Sasakawa provided the private funding to secure the seeds and fertilizers. Together, they formed the Sasakawa Africa Association.
And despite the terrible infrastructure, no roads, no organized markets, his methods still managed to triple maize yields in several developed African nations.
It's a testament to his sheer willpower. He remained fiercely active right up until his death at age 95 in 2009.
And his late-life views on the future of our food supply were incredibly stark, weren't they?
Very stark. He pointed out that humanity is mathematically required to double the global food supply by the year 2050.
Double it.
Double it. And because he firmly believed we are out of arable land and cannot chop down the remaining forests, he became a passionate, highly vocal advocate for genetically modified organisms, or GMOs.
He viewed modern GMOs as simply a faster, more precise continuation of the manual crossbreeding he did with tweezers in Mexico.
Exactly. It all goes back to a continuous warning he delivered during his 1970 Nobel speech. He called it the population monster.
The population monster.
He knew that agricultural technology could only provide a temporary fix if human reproduction continued exponentially. Now, later on, by the year 2000, he did believe that technology could feed 10 billion people sustainably.
But there was a catch.
A huge catch. He raised the chilling question: will farmers actually be permitted to use the technology? He warned that while affluent nations can afford the luxury of lower-yield organic methods, the chronically undernourished simply cannot.
So we are really left looking at a historical figure defined by profound contradictions. A humble farm boy from Iowa who became a global scientist navigating international geopolitics.
A humanitarian driven by deep empathy who relied on highly controversial, harsh industrial chemicals.
A man who won the Nobel Peace Prize but fought all his battles in muddy fields and active war zones. You really cannot separate his legacy from your daily life.
No, you can't. Every time you, the listener, walk through a fully stocked grocery store, every time you see an aisle overflowing with grain and cereal, you are looking at the direct physical legacy of his lifelong obsession with filling bellies.
He proved that human ingenuity can, at least temporarily, outpace human starvation.
But he also left us with a ticking clock. He warned that the Green Revolution didn't solve starvation forever. It only bought humanity a breathing space.
A breathing space. And as we rapidly approach the year 2050, the exact year he warned we would need to double our global food supply without plowing any new land, we have to ask ourselves a very uncomfortable question.
Have we squandered the breathing space he gave us?
Exactly. Or are we ready to engineer the next revolution? Think about that the next time you hold a piece of bread. Think about the 1 billion lives saved and the billions more that will depend on whatever revolution comes next.